So this is 3.3, B as in boy, second video on the unit circle and circular functions in algebra or in trig. One of the things that you want to notice is that theta and s are, closely related. I'm not going to say they're totally related, but for the most part in this course they are. So we're actually going to just say that the sine of theta equals y and the cosine of theta equals x. And before in the last video we said the sine of s is y and the cosine of s is y. And so really doesn't have any problem here, but here is where it gets a little tricky. In your calculator you have what is called a DRG button, and let me get a picture of a calculator here. So here's the DRG button. The DRG button will determine whether this says degrees, radians, or gradients. And we're not going to use that button at all. But to go back and forth, you have to push through that. So right now when you're given an angle, like if you're looking for the sine of 30 degrees, you're going to leave it in degree because 30 degrees is a degree. If we're using radians, if we're using a pi, so if I want to find the sine of 3 pi over 2, this is in radians, so it has to be in this measure. If it's not in that mode, it's not going to give you the correct answer. So if I'm looking for the sine of 30 degrees, I'm going to use the degree button. If I'm looking for a sine and there's a pi in it, then I know it's in radians. Or if, I guess I should say, there's going to be a pi in it, or it's not going to have a degree on it at all. It'll just say sine of 20, and it won't have a degree. You have to use the radian mode, or you will not get the right answer. So for example, in example 1, it says sine of 3 pi over 2. Put it in the radian mode, and then take 3 times pi, answer, divide by 2, take the sine of it, and you'll get -1 for your answer. The same is true with the cosine of 3 pi over 2 and the tangent of 3 pi over 2. Okay, here's where it gets nerdy cool. Let's say I'm looking for the value, the exact value of the cosine of 7 pi over 4. Okay, so 7 pi over 4. 7 pi over 4, if we use our handy dandy little chart here, it's right there. It is a 315 degree angle, or an angle right there that's 45. Here are my 2 points there. Now if you remember right, the first point is the same as cosine, and that is the square root of 2 over 2. So the cosine of 7 pi over 4 is the square root of 2 over 2. The sine of that is going to be my y value, negative square root of 2 over 2. Okay, you can figure that out by hand. I'm just using the table here just to, because it's quicker and easier to show it to you. But if you were to do it by hand, you would just go, this is square root of 2 over 2, this is negative square root of 2 over 2, and we don't know that yet. So let's pretend that that goes away, and we're trying to find that out. I know that this is a 45 degree angle, which means this is 1, this is 1, this is square root of 2. So the sine of a 45 degree angle in the fourth quadrant is negative. I also know that the sine is opposite over hypotenuse, which is negative opposite over hypotenuse. Got to get rid of my radical by multiplying top and bottom by that, and I get negative square root of 2 over 2, which is this number right there. So you can figure that out by hand. You don't need the table, you don't need a calculator. It's not really rocket science. Well, maybe it kind of is rocket science. They do use trig for rocket science. All right, so that is how you do A in example 2. Now let's say we're doing B and we're trying to find the tangent of negative 5 pi over 3. All right, let's say we don't have that unit circle. What is 5 pi over 3? Well, we break 180 into 3 pieces, which is 6, or 60. 60 times 5 is 300. So 300 is 5 pi over 3, and it says we're going in a negative direction 300. So we're going all the way around to 300, which means there's a 60-degree angle left. So there's our 60-degree angle. So if I'm going to take the tangent of this, I'm just going to call it the tangent of theta. That's going to be the opposite over the adjacent. The opposite of a, give me a better blue color here. The opposite of tangent, let's put the numbers up there, square root of 3, is the square root of 3, and the adjacent is 1. And we're in the first quadrant, so it is positive. So the tangent of negative 5 pi over 3 is going to be the square root. So in other words, we were able to figure that out without a calculator. Really, we didn't even need the circle graph or the circle diagram that I have there at all either. But not too bad. All right, let's say that we're going to try to find C. Cosine of 2 pi over 3. All right, how many 3's are there in 180? There are 60. Multiply 60 times 2 is 120. So cosine of 2 pi over 3 is really a 120-degree angle. And 120-degree angle, let's see if I can get rid of this junk here. 120-degree angle is going to be right here, which is a 60-degree. 1, 2, square root of 3. And cosine is negative in that quadrant. And that's going to be adjacent over hypotenuse. And the adjacent is 1, the hypotenuse is 2. And it's negative in that quadrant. Cosine of 120, or cosine of 2 pi over 3, is negative 1/2. Okay? So that section is how you find exact circular function values. Now really, the only thing I'm finding that's different between circular function values and trig function is trig function deals with degrees and function values deal with radians. So, you can find them the same way. It's kind of the same principle. You're just, for example, cosine of 2 pi over 3, you're trying to find the function value and you got negative 1/2. Well, if you plug in your calculator the cosine of 60, or the cosine of 120, you're also going to get negative 1/2. It just depends on whether you're using the radians or the degrees. So the upper level math, calculus, etc., is going to be using radians a lot more often. So approximating circular function values. Let's say that you're just looking for the cosine of 1.85. Now this is in radians because there's no degree sign up here. No degree sign, it's in radians. Your calculator is in the radian mode, and you just type in 1.85 cosine, and it'll give you a number. It's the same with all the rest of them there in example 3. The only difference, it would be like cotangent. I guess it's not really difference. Cotangent 1.3209. We can't do cotangent on our calculator, so we're going to say the tangent. We're going to say cotangent equals 1 over the tangent of 1.3209. Okay, so the cotangent of 1.3209 is going to be 1 over the tangent. So instead of doing anything with cotangent, we just find the tangent of 1.32 over 9 and put 1 over it and divide it out. Same way finding secant, we use the cosine there. So a common error in trigonometry is using calculators in degree mode when radian mode should be used. If you're finding the circular function it has to be in radian mode. If you're using radians, it has to be in radian mode. Alright, so example 4 says finding a number given its circular function value. So we're trying to find the value of s in the interval 0, pi over 2 if cosine of s is 0.9685. Alright, what this means right here is s value is somewhere in between 0 and 180 degrees, which in radian is pi over 2. So our s value is going to be somewhere in there. All students take calculus. So it could be positive or it could be negative. We'll just wait and see. So what are we looking for? We're looking for the value of s. We're looking for the length of the arc. Alright, so what I'm going to do given this, whoops, I kind of moved over a little bit too much there. Okay, in order to do this properly, all we have to do is we're looking for the cosine of s is 0.9685. We're looking for s, so we're looking for the arc length, or the degree if we were in degrees rather than radians. So we're going to take the arc cosine of 0.9685, and it's going to give us a measurement of 0.2517. So that's how long that arc is. Okay, so part B of example 4 says that we've got this value in the interval of pi 3 pi over 2. So the interval of pi to 3 pi over 2 is somewhere in here. Third quadrant. Okay, so we have 3 pi over 2 and pi. Okay, we know we're looking for the sine of s. One thing that we know, or I know I guess, just from past experience, is whenever the tangent is 1, you know, tangent is, that's an s, tangent is y over x. And if we have y over x, and if we're looking for the tangent being 1, that means y has to be 1, x has to be 1, or 5 over 5, or 6 over 6. Either way, the lengths have to be the same, which means when we have a value here, in this case it's going to be a 45, because that's the only one where this is a 1 and this is a 1. Okay, and one of the things I know all students take, tangent is positive in that quadrant, so that's going to help. So when the tangent is 1, then the x and y values have to be the same, and that only works in a 45-degree angle. So the exact value is going to be this one right here. So all I need to do is change this, which is 180 plus 45, so 225-degree angle. I just need to change that into radians. So I'm going to multiply that by pi over 180, and that ends up being 5 pi over 4. So 5 pi over 4 is the exact answer when the tangent of s is 1. So basically what I'm saying is the tangent of 5 pi over 4 is 1, or the tangent of, in degrees, 225 is 1. But this is what they want since we're talking with circular function values. Okay, so that's it for lesson 3.